let's see. The area of a regular pentagon with sides A is PA squared, with P given as that. The pentagon in Washington, D.C. has an inner side of length 360 feet and an outer side of 290 feet. Write an integral expression to express the area of the roof of the pentagon according to these dimensions. Okay, so that would be the integration. The integration from 360 to 920 times the derivative of PA squared, where P is a constant. So the derivative is 2AP. So that's 2AP dA. If you want, you can cancel that with that. So could go with that, I think. A dodecahedron is a platonic solid with surface area consists of 12 pentagons, each of equal area. By how much does the surface area of the dodecahedron increase as the side length of each pentagon doubles from 1 to 2? So I think because it's a double and it's a volume, then the increase would be a doubling squared. I think, which is 4. So let me just check the answer at the back here. Yeah, yeah. So the area increases. So is it what the area they wanted? Yeah. Um, so with P as the previous exercise, each of the 12 pentagons increased from area from 2 to 4. So the net increased the area of 36 to, oh, okay. Um, I might be picturing this wrong in my head. A dodecahedron is a surface consists of 12 pentagons, each of equal area. By how much does the surface area of the dodecahedron increase? Okay, so yeah, it'd be 12 times 1 to 2, 2AP dA. So that would be 24 A squared P over 2, 1 to 2, 4, 3 over 2P, 3 over 2 times 24P. So that's 36P. Yeah, okay, that's the answer, isn't it? Okay, great. Great. Okay, so this is the same. It's 20 equilateral triangles. By how much does the surface area increase as the side length of each triangle doubles? Okay, so it's 20A to 2A. And then for an equilateral triangle, the area formula is, let me just put it up the top here. It's root 3 over 4A squared, I think, is the area for an equilateral triangle of sides A. So that would be 2 times root 3 over 4A dA. So that would be 20 root 3 over 4 A squared. A to 2A. Well, actually, maybe I don't want to mix things up, so I'll just call that X instead, because the A is being used for something else in this question. Okay, so that would be 4a squared minus 1a squared. So that would be 3a squared times root 3 over 4 times 20. So it's 20 times root 3 divided by 4. 4a squared minus 1a squared. So that's 3a squared. So that is 15 root 3a squared. Unfortunately, I don't have an answer at the back to check for that one. Write an integral that quantifies the change in the area of a surface of a cube when its side length doubles from s to 2s. So the surface area of a cube is 6x squared. So that would be 12x dx. Let's check that one. 219. Yeah, 12x. Yeah, I can take the 6 out. Okay, so that one's definitely right. And we know that one's right. Okay. Write an interval that quantifies the increase in the volume of a cube when its side length doubles from s to 2s. So that's s, 2s. The volume is x cubed. So that would be the derivative 3x squared dx. Write an integral that quantifies the increase in the surface area of a sphere as its radius doubles from r to 2r. And the surface area of a sphere is 4 pi r squared. So that would be 8 pi r dr, I think. 8 pi r dr. Yep, okay. Write an integral that quantifies the increase in the volume of a sphere, which is 4 over 3 pi r cubed. So as a radius doubles, so that's r to 2r, and then bring that 4 pi r squared dr then. Don't have the answer at the back for that one. Okay, that's another batch of questions done for today. Let's wrap it up there. Hopefully those even questions are correct. Maybe I'll just have a quick check before I close it. So that's what I did was the derivative. So it's 2pa. So 2 over 4. So I think, yeah, I think that looks okay. We know that's okay. This one is similar to the last one. You have to have the 20 here, and it's the this is the equilateral triangles, and I think this is the area for an equilateral triangle, so it's derivative. So because I'm using the formula a half x sine 60, and sine 60, you see, is root 3 over 2. So I think that's right. Write an integral that quantifies the increase in the volume of a cube when its side length goes from s to 2s, and that's the derivative there. I know that's right. And then that's the derivative of the volume of a sphere, radius from r to r. So I think that's all right. So that's up to 222 done.